We have here a rhombus. It says find the following values for this rhombus. Leave answers as exact values. So this is pretty common in geometry. They just don't want you to use a calculator and round for your final answer. So for instance, if you get an answer that is not a perfect square and it's say like √5, then you just don't carry out the math and use a √5 and get some estimated value. Just leave the √5 in the answer. So it's actually less work for you to do. So what we have here is segment AE is 5, segment BE is 7. And we do know, again, it's a rhombus. Now, I made it look like a square, and that's simply because the review I pulled it from made it look like a square too. So we can't assume, for instance, A, B, C, and D are right angles, even though they may have that appearance. We can't make that assumption. But we can make the assumption, though, is that we have this intersection right here, and that intersection, the diagonals that intersect form a right angle. Now, it won't be isosceles like in a square. Those four triangles will not be isosceles, but we can do some additional work to find out the information that's needed here. And the first thing they want is segment AC. What's the measure of that? Now, if I have AE is 5, I know EC is 5. And that's because we know in parallelograms and therefore rhombuses, I believe that's the correct way to say it, that we have diagonals that bisect each other. So for instance, here we have those two segments are congruent. So I can say this has a measure of 5 as well. And in total, AC has a measure of 10. Perimeter of the rhombus. Okay. So I know nothing about the sides. That's a big old question mark right there, right? However, I can use the fact that we have these right triangles embedded in the figure. And I could simply, and what do we know about rhombuses as well? We know that all 4 sides are equal. So if I find one side, I find them all. You could technically do the math on all of those triangles inside, but they're all the same. All right, so I'll just take the top one here. These are kind of hard to do sometimes, but we'll just say, for argument's sake, that that is a right triangle, and we have a length of 7 and a length of 5, and we just need to find what we'll just call this x. All right, so I have the 2 legs, and I'm actually finding the side opposite of the right angle. So that's in Pythagorean theorem, that's C, correct? So what I'm looking for is, I'll go ahead and put up Pythagorean theorem here, b squared equals c squared. And then I know we can just call A 7, B 5, and C squared. Well, I'll call it X squared, because that's what I called it. And then from this point on, it's simply using algebra techniques to solve. 49 and 25, what is that? 74. I'll double check that just to be sure. 49 and 25 is indeed 74. And so this is where we would definitely, I don't think we can reduce that. I don't think it's divisible by any perfect square. No, 74 divided by 16. Yeah, 74. Half of 72 is 36. Yeah, it's game over there. We'll just leave it as √74. Okay, so we have √74 here. And of course, all the way around, for clarity, I'll just write this out. √74. √74. All right, almost there. How do we find the perimeter? We just add all 4 sides. Remember, when you add square roots, you're just adding the coefficients in front of them. They're all the same square root, so you can add them accordingly. So we have basically, or you can just say 4 times √74. And, ultimately, it's just 4 √74. Now, if you were to estimate it, for instance, on the calculator, if they said, okay, just take the answer and round it, you would get 34.409. I'll just say roughly 34.4. And that's your final answer. Thanks again for watching.